Hi, I'm doing AS Further Maths under the edexcel specification. I'm doing Statistics 1, and today I'm going to be teaching discrete random variables. So, a discrete random variable is a variable whose value depends on a random event, and the fact it's discrete means it can only be certain numerical values. And so more observations take you closer to the expected value, which is basically the mean. And so the expected value is denoted by E and then X, which is sigma X times the probability of X. So it's every value of X times the probability added together. And if X is a discrete random variable, so is X squared. So you also need to do the expected value of X squared, which is basically every value of X squared times the probability of X added together. So this means, let's say, for example, you had an even dice, okay? And so 1, 2, 3, 4, 5, and 6. And that means every probability is 1/6. So for the expected value of X, you'd have 1/6 plus 2/6 plus 3/6 because it's timesing. And then for X squared, it would be 1/6, 4/6, because only the value of X changes, the probability stays the same. And that's really important to know. Okay, so now I'm going to be talking about variance. And so variance basically measures how far values are spread out from the mean. So the variance of X is var, brackets X, and that is denoted by the expected of X squared minus the expected of X the whole squared, which basically, in normal terms, is the mean of the squares minus the square of the mean. Okay, so now I'm going to be moving on to formulas. And so to begin, let's take X as a discrete random variable, and the G is a function. And therefore, the function of G applied to the discrete random variable X is also a discrete random variable, and therefore can be used to find the mean and the variance. So to find the expected value of the function G applied to the discrete random variable X, you do the sum of, or sigma, the function of G applied to X, multiplied by the probability of X. And then moving on, if X is a discrete random variable and A and B are constants, then the expected value of AX plus B is the same as the expected value of X times by A plus B. And if X and Y are discrete random variables, then the expected value of X plus Y is the same as the expected value of X plus the expected value of Y. And finally, this works for variance as well, but if X is a discrete random variable and A and B are constants, then the variance of AX plus B is A squared, the variance of X, because when you're doing variance, it only focuses on values that have the X, so the B is completely ignored. Okay, so now we're going to be moving on to practice. And so here we have a question where two fair 10p coins are spun, and X represents the value of the coins when they land head up. So we need to find the expected value of X and the variance of X. So to begin, we need to write down the probabilities. So there are 3 expected outcomes, and that can either be 0, when both coins land head down. It can be 10, where one coin lands head up and the other one lands head down. And 20, where they both land head down. And so the probability of 0 is a quarter, the probability of 10 is a half, and the probability of 20 is another quarter, because 10, it can be either coin, whereas for 0 and 20, it has to be both coins that land in the same direction. So then we do the expected value of X, and we know that it's the value of X multiplied by the probability of that X happening. So that equals 0 times a quarter, which is 0, half of 10, which is 5, and a quarter of 20, which is also 5. So the expected value of X is 10. Now we need to do the variance, which is equal to the mean of the squares minus the square of the mean. So that means we need to do, so we already have the expected value of X, so we need to square that, so that's 100. Now we need to do the mean of the squares, so we do square of X times the probability of X. So half of 100, because 0 doesn't matter, so we have 0 plus half of 100, which is 50, plus a quarter of 400, which is 100. So that equals to 150 minus 100 because this is the mean of the squares and that's the square of the mean. So that equals to 50. So the variance of x is 50. Okay, so now we have an equation where x is an unknown and we're given y, which is a random variable which has like a function of x in. So here we have to basically find x. So make x a subject. So we have x is equal to 50y plus 150, because we take it from here, which is the equation of y. And we know then the expected value of x is 50 times the expected value of y plus 150. And obviously we know the expected value of y because it's given to us in the question, which is 5.1. So we know that the expected value of x is 50 times 5.1, which is 255 plus 150, which is equal to 405. And now we need to do the variance of x. And so we take the same base equation, so x equals to 50y plus 150. So the variance of x is very similar, which is 50 squared, because obviously if you remember we square the term that has like the coefficient of x, or y in this case, because we're focusing on y. So it's 50 squared, the variance of y, and so it's 50 squared times, because we're already given the variance of y, 2.5, which is 6,250. Okay, so now we have a very similar question with a few more unknowns, so it looks a bit harder and it's got a few extra steps. So we're going to start off the same way because we're given y is the discrete random variable, which is 3x minus 1. So we're going to make x the subject. So that means x is equal to y plus 1 all over 3. And so then we need to find the expected value of x, which is equal to the 1 over 3, the expected value of y, plus 1/3. And so we know the expected value of y is minus 2.5. So it's 1/3 of minus 2.5 plus 1/3, which is equal to minus 0.5. And so that's the expected value of x. And now we need to find the expected value of x squared, which looks pretty difficult from this. But all you need to do is, so we have the variance of y, and so let's go variance of x. I know we're not told to find it, but it helps with our equation. So the variance of x is equal to 1/3 squared, so that's 1/9 of the variance of y. And that is equal to 1.55. So now we have the variance of x. And if you remember, variance, so the variance of x equals to the mean of the squares minus square of the mean. So that means it's equal to the expected of x squared minus the expected of x the whole squared. And we have the expected of x, so we need to rearrange the equation. So first let's write it out. So we have the expected of x squared minus brackets minus 0.5 squared. And obviously we have the variance of x, so that is 1.55 is equal to the expected value of x squared minus 0.5 the whole squared. And so by rearranging, we find that the expected value of x squared is equal to 1.8. We need to do the expected value of x, and we know that's equal to minus 0.5, and so that must equal to minus 2 times 0.3, so that's minus 0.6 minus a, 0 doesn't matter, plus b plus 2c. So let's add the 6 to the other side. So we have 0.1 is equal to minus a plus b plus 2c. And then we can do the expected value of x squared. And so we do the same thing. So that's 1.8 is equal to, so that's 4 times 0.3. So 1.2 plus a, because minus 1 squared. 0 doesn't matter still. Plus b plus 4c. And so we can minus 1.2, so that's 0.6 is equal to a plus b plus 4c. So now we have two simultaneous equations, and we can put that into a calculator, and it gets solved. And then because there's 3 unknowns, we need to have 3 different simultaneous equations. So now we have the easiest one. So we know that all probabilities add up to 1. So we have 0.3 plus 0.25 plus a plus b plus c is equal to 1. That means that a plus b plus c is equal to 0.45. And then we can put that into a calculator and it can solve it for us. Or you can do it in the way of matrices. I just prefer to put it in a calculator because it's faster. And so then we have a is equal to 0.2, b is equal to 0.2, and c is equal to 0.05. And that is how you solve an equation where you get, and that is how you solve a question where you're given unknowns, where you have to work different things out and put it into forms you already know. And that's all. Thanks for watching. Bye.